Welcome to Astronomy Daily, your go-to source for the latest and most exciting space and astronomy news. I'm Anna, and I'm thrilled to bring you another episode packed with fascinating discoveries and developments from the cosmos. Today, we'll journey across the universe, starting with some intriguing updates about Betelgeuse, that enigmatic star that's been keeping astronomers on their toes. We'll then zoom in on Mars, where NASA's Perseverance rover has been making some impressive climbs and discoveries. But that's not all. We'll also delve into some mind-bending cosmic phenomena, including a puzzling radio signal that's challenging our understanding of the universe. And we'll round things off with some groundbreaking observations from the James Webb Space Telescope that are reshaping our views of the early universe. So buckle up and get ready for a cosmic adventure as we explore the wonders of our universe together on Astronomy Daily. Let's turn our attention to one of the most intriguing stars in our night sky, Betelgeuse. This red supergiant, the 10th brightest star visible from Earth, has been puzzling astronomers with its peculiar behavior in recent years. Now, scientists have come up with a fascinating new theory that might explain its mysterious dimming and brightening. Between November 2019 and March 2020, Betelgeuse visibly dimmed, leading to speculation that it might be on the verge of going supernova. Then, just a couple of years later, it suddenly brightened by 50%. These dramatic fluctuations left astronomers scratching their heads. Enter the latest hypothesis. Betelgeuse might have a companion. That's right, this cosmic giant may not be flying solo after all. Scientists have affectionately dubbed this potential stellar sidekick Beetle Buddy. According to a study accepted for publication in the Astrophysical Journal, researchers have ruled out every intrinsic source of variability they could think of to explain Betelgeuse's recent antics. The only hypothesis that seemed to fit was the presence of a companion star. Computer simulations suggest that if Beetle Buddy exists, it acts like a celestial snowplow. As it orbits Betelgeuse, it pushes dust out of the way, temporarily making Betelgeuse appear brighter to us here on Earth. While we don't know for certain what Beetle Buddy might be, the best guess is that it's a star about twice the mass of our sun. Some researchers even speculate it could be a neutron star, though that's a more exotic and less probable scenario. This companion star theory not only helps explain Betelgeuse's recent behavior, but could also provide insights into the star's pulsations. Betelgeuse has two distinct pulses, one about 6 years long and another just over a year. Understanding which of these is the star's fundamental mode could help astronomers predict when Betelgeuse might go supernova. The next step for astronomers is to try and observe Beetle Buddy directly using a telescope. This potential companion star, if confirmed, could prompt us to reconsider our understanding of neutron stars and their behavior. It's a reminder that even well-known stars like Betelgeuse can still hold secrets waiting to be uncovered. Next up, let's get an update from Mars, the favorite planet of many of you. NASA's Perseverance rover has been making steady progress in its challenging ascent of the Jezero Crater rim on Mars. Over the past week, the rover has been carefully navigating the steep terrain, which is composed of loose Martian soil called regolith. This makes the climb particularly tricky, as the rover's wheels tend to slip on the steepest sections. To overcome these obstacles, the science and engineering teams at NASA are working closely together to plan slow, careful drives. They've identified a relatively clear path up the crater rim, which they've aptly named Summerlin Trail, after a popular hiking trail on Mount Rainier back on Earth. As Perseverance makes its way along this trail, it's not just focused on the climb. The rover is constantly observing its surroundings, using its advanced instruments to study the Martian landscape. The SuperCam and Mastcam Z have been busy capturing images of rocks on the ground and on a distant hill called Crystal Creek. But that's not all. Perseverance has also been turning its gaze skyward. Last week, the Mastcam Z camera captured stunning images of Phobos, one of Mars' two moons, as it transited in front of the sun. This celestial observation adds another layer to the rover's scientific repertoire. The rover's next target is an outcrop of rocks called Pico Turquino. Here, the science team plans to conduct detailed studies using the PXL instrument and the newly reactivated Sherlock. These instruments will provide valuable data about the composition and structure of the Martian rocks, potentially offering new insights into the planet's geological history. Despite the excitement of reaching the ancient stratigraphy exposed in the crater rim, the Mars 2020 team is maintaining a steady focus on documenting the current surroundings while carefully navigating this challenging ascent. Next, a discovery that has astronomers scratching their heads and say, now what? In a groundbreaking discovery, astronomers have stumbled upon a cosmic radio pulse that's unlike anything we've ever seen before. This newly detected radio transient, named ACE-Cap-J 1935 plus 2148, has a cycle of nearly an hour, making it the longest ever recorded. Typically, when we point our radio telescopes into space, we detect brief bursts of radio waves from distant parts of the universe. These bursts, known as radio transients, can behave in different ways. Some appear once and never return, while others blink on and off in regular patterns. Most of these are believed to come from rotating neutron stars, or pulsars, which emit consistent pulses of radio waves like cosmic lighthouses. But ASCAP-J 1935 plus 2148 is something entirely different. Its 53.8-minute cycle is far longer than anything we've observed before. What's even more intriguing is that this celestial oddity exhibits three distinct states. In one state, it produces bright, linearly polarized pulses lasting up to 50 seconds. In another, it emits much weaker, circularly polarized pulses lasting only about 370 milliseconds. And in its third state, it goes completely quiet, with no detectable pulses at all. So what could be causing this bizarre behavior? Scientists are still scratching their heads, but the prime suspect is a slow-spinning neutron star. However, our current understanding of neutron stars suggests they shouldn't be able to have such a long period. Another possibility is that it could be a white dwarf, the Earth-sized remnant of a burnt-out star. But white dwarfs aren't known to produce radio signals like this. The discovery of ASCAP-J 1935 plus 2148 might prompt us to reconsider our decades-old understanding of neutron stars and white dwarfs. It could provide valuable insights into the physics of these extreme objects and how they emit radio waves. What's particularly exciting is that there might be many more objects like this out there, waiting to be discovered. We were quite fortunate to catch sight of ASCAP-J 1935 plus 2148, given that its radio emissions are only detectable for a tiny fraction of its rotation period. As we continue to explore the cosmos, discoveries like this remind us that the universe still has plenty of surprises in store. They challenge our existing theories and push us to expand our understanding of the cosmos. Now let's turn our attention to a critical issue facing one of the world's leading space agencies. A recent report by the U.S. National Academies of Sciences, Engineering, and Medicine has raised some serious concerns about NASA's future. Titled NASA at a Crossroads, this report doesn't mince words about the challenges ahead. The report identifies several key issues that NASA needs to address urgently. These include outdated infrastructure, pressure to prioritize short-term goals, budget mismatches, and inefficient management practices. It also points out that NASA's reliance on commercial partners may not always be strategic. What's particularly striking is the report's recommendation that NASA should rebalance its priorities. It suggests increasing investments in facilities, expert workforce, and cutting-edge technology development, even if it means delaying the start of new missions. This is a bold stance that underscores the severity of the situation. The environment in which NASA operates has become increasingly complex. Rapid technological advancements, competition for talent with the commercial space sector, and a declining federal discretionary budget are all putting pressure on the agency. Add to this the lack of timely congressional authorization acts and increasing competition from countries like China, and you can see why NASA is at a crossroads. The report's authors, led by former Lockheed Martin CEO Norm Augustine, emphasize that this is not a time for business as usual. They argue that NASA's continued success is at risk due to the mismatch between its budget and its programs, a focus on short-term objectives, and aging infrastructure. What does this mean for the future of space exploration? Well, it's clear that tough decisions lie ahead. NASA may need to make some difficult choices about which missions to prioritize and which to delay or cancel. The agency might also need to redirect funds from exciting new projects to less glamorous, but essential infrastructure upgrades. This situation raises important questions about how we as a society value space exploration and scientific research. Are we willing to invest in the long-term health of our space program, even if it means fewer headline-grabbing missions in the short term? The answers to these questions will shape the future of space exploration for years to come. The James Webb Space Telescope has once again pushed the boundaries of our understanding of the early universe. In a groundbreaking discovery, astronomers have used the telescope to peer back an astounding 13 billion years, revealing surprisingly lonely supermassive black holes powering ancient quasars. This finding has left scientists scratching their heads. You see, these isolated black holes shouldn't have been able to grow to such enormous sizes, especially when the universe was just a few 100 million years old. It's like finding a fully grown adult in a nursery. It just doesn't add up. The team studied 5 of the earliest known quasars, formed when the cosmos was a mere infant at 600 to 700 million years old. What they found was puzzling. The environments around these quasars, called quasar fields, varied widely. Some were packed with galaxies, as expected, but others were surprisingly empty, lacking the cosmic buffet needed to feed a growing supermassive black hole. This discovery challenges our current models of how these cosmic giants came to be. Previously, we thought supermassive black holes needed densely populated neighborhoods to grow rapidly. But now it seems some of these ancient behemoths were sitting in cosmic deserts with little to no galactic company. The implications of this finding are far-reaching. It forces us to reconsider our theories about black hole growth and even galaxy formation itself. The current understanding involves a vast cosmic web of dark matter guiding the formation of early galaxies and quasars. But these lonely quasars don't quite fit into that picture, so what's going on? Well, one possibility is that these quasars are surrounded by cosmic dust, hiding their galactic neighbors from view. Alternatively, there might be entirely new mechanisms at play, allowing these black holes to grow rapidly even in isolation. As we continue to explore the early universe with the James Webb Space Telescope, we're bound to uncover more surprises. Each new discovery brings us closer to understanding the cosmic dawn, but also reminds us how much we still have to learn about our vast and mysterious universe. And that wraps up today's episode of Astronomy Daily. We've covered some fascinating developments, from Betelgeuse's potential companion star to the Perseverance rover's challenging climb on Mars. We've also explored the discovery of the longest cosmic radio pulse ever detected and discussed NASA's current challenges. Finally, we delved into the James Webb Space Telescope's surprising observations of ancient quasars. If you're hungry for more space and astronomy news, head over to our website at astronomydaily.io. There, you can sign up for our free daily newsletter. Check out our sponsor links for some great deals, and catch up on all the latest news with our constantly updating newsfeed. You'll also find all our previous episodes available for listening. Don't forget to follow us on social media. Search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok to stay connected with us between episodes. This is Anna, thanking you for tuning into Astronomy Daily. Keep looking up, and we'll see you next time.